Thanks for coming in this morning. It's good to see so many people here today. If the panelists would like to come up.
Morning. It's bright in this morning. Hi. Good to see you. Morning.
So what we're going to be talking about in the next session is the future of LTE, and really sort of what does the next 3 years bring? You know, what does the next 3 years look like? And in order to do that, we brought a couple of semiconductor guys along, and we've also got Ashok Chatterjee, who is chairman of the 3GPP project coordination group. And the reason for that is that that's a group that's looking at what specifications, what solutions need to be in place on a standards point of view, so that what all you guys are looking for in the future is actually going to be there and ready to work. And then we've got two semiconductor guys. We've got Stephen Turnbull, who is from Freescale. And what I'll do is I'll ask them all just to say a few words about their own companies and their positions. And we've also got Noi Kukuk, who is from LSI. So perhaps we can start with Ashok. You can do it from there if you like.
Shall I go jump into the thing right away?
No. If you can just say a few words about who you are, that's fine.
What I noticed, and it's not a predetermined thing, I came here and I saw that the future of LTE is ties. What's wrong with us? We didn't consult among each other, but we thought that that's probably the best way to impress you guys. Because technology, when LTE becomes all-pervasive, you'll not even notice it. But you'll remember that there was a panel, everybody was wearing a tie. I work for Ericsson. I'm the chairman of the project coordination group, which manages 3GPP. It started about 14 years or so back, and you have seen its journey from the end days of GSM all the way to now LTE Advanced. So it will be an honor for me to give you some glimpse of what we can find in the technology going forward, and then probably my other panelists are going to take over and find out what's going to be coming out of that.
Okay, thank you. And Stephen Turnbull.
Good morning. I hope my voice holds out for the session this morning. I've got a bit of a cold, so apologise if I'm a bit raspy. Yes, my name is Stephen Turnbull. I work for Freescale. If you don't know Freescale, it's an embedded processing company. Our key products and strengths are in high-performance processors and in microcontrollers. And we have a very significant focus and drive a significant part of our revenue from the networking and the wireless space. My specific interest and focus is the wireless access market, and we pull together our broad portfolio of IP to do SoCs for base stations, everything from femto through to macro. And so we obviously have a huge interest in LTE. The move to kind of all IP networks plays well to our strengths and our focus. And of course, as we advance the standards, though, we have more and more to do to keep up from a silicon perspective. So that also gives us some challenges, but it's fun and interesting, the speed at which the market's moving.
Okay, thank you. And then finally, Noi.
Good morning. My name is Noi Kukuk. I work as a marketing head for the LSI on the networking solutions group. Similar to Stephen, our job is to take the standards and make it work in the silicon, basically. So we use multiple different technologies for that. Obviously, anything from the silicon technology to IP development and to make the mobile broadband work. So I spent over 20 years in the system side of the equation. So now I'm on the silicon side for the last while.
Okay, thanks. Well, just to let you know what the format's going to be for this session. First of all, I'm just going to say a few words about where I think we are and also where we're going. We're then going to have a short presentation from Ashok looking at what's going on in 3GPP, but more specifically, the sorts of things that are likely to be going into release 12. So that's looking a little bit further forward from where we are today. And then I've got a series of questions. There's 4 questions for the panelists, just to give your their thoughts on how they see things developing, you know, what's going to be important in the future. And after that, there'll be a Q&A for an audience Q&A. So please, if you have any questions, get those ready for that part of the session. So where are we now? Well, I've just picked out a few numbers here that have been published recently. These are from the GSA. And I think that's pretty significant. And what I feel is in many ways, 2012 is the year of LTE. Because if you just look at the number of operators that are bringing out new LTE services, we've got 105 so far. We're expecting another 54 before the end of the year. That's a very significant increase during this year, and the majority have come in during this year. In addition, there's now more than almost 470 different devices. Obviously, a lot of those are smartphones, but there are other devices out there, dongles and other pieces of equipment. So LTE is now widely available on devices. There's been some fairly significant build-outs by operators, very recently in the US, but before that in places like Korea, Japan, and so on. And that's largely been driven with macro cells, so providing good coverage in those target areas where operators see their main customer base being. What's now being talked about, and for those of you who were here on Monday, there was the Small Cell Summit, where there was a lot of discussion about small cells, and it seems to me there's actually a small cell almost for every single situation. And I think that's going to be all about building out the coverage beyond those initial markets. There's certainly been a lot of discussion about the availability of bands for LTE. Some operators have issues on that score. Some countries have issues on that score. So that's something that's got to be sorted out. And what you're seeing now is actually a very small user base, although it is growing very rapidly when you look at the numbers, that are using a relatively high amount of data. I don't know whether anyone has access to the stats in Chicago, but I suspect this week a lot of the bandwidth in Chicago has just been testing how fast the network is. I've been in a couple of restaurants where at least 5 people have been doing that simultaneously on their phone. So, you know, I think we're at very early days, but that network is getting out there quite quickly. So then the next question is, well, where are we going to be in 3 years' time? Well, I've got some numbers here. This first numbers come from the Pyramid Research Group. And what we're seeing there is they're forecasting almost 600 million LTE subscriptions by 2016. So that's a significant growth on the numbers we've got today. 4G LTE revenues projected to exceed 265 billion. So that's a significant market opportunity. And that's, again, into 2016. So what impact does that have on what you see out there? Well, I think you will start to see most, if not all, phones being LTE capable. That's something that the industry's got to move towards at some point. Is it going to happen within 3 years? Well, it could. It may take longer, I don't know. We also need global roaming. That's something that's actually quite difficult with LTE, and that goes back to all the different bands that are being allocated. At the moment, what seems to be more important is gaining that bandwidth rather than necessarily being able to build phones that with a limited number of bands can roam globally. So that's another area that needs to be addressed. And then we need wide coverage. As I mentioned, what we've got at the moment is mainly macro cells. When you start putting in small cells, put small cells in the areas where there's a lot of usage to provide additional bandwidth. You put small cells on the periphery to extend the reach. You can put it in rural areas. You can put it in buildings. So there's a lot of work to do to expand the coverage. And then the other thing that's been talked about is machine-to-machine, the Internet of Things. That's clearly an opportunity for carriers now to build business cases where it makes sense to support machines over LTE going forward. Because if that move to machine communication goes on to something like GSM, that means carriers have got to continue to deliver GSM services for a long time, and that may not be the best use of their resources. And assuming that change takes place and machine-to-machine mostly goes on to LTE, which is possible but may not happen, then you have the opportunity to have not only LTE everywhere, but just LTE as a network service. And that then allows operators to start turning off 2G and 3G. I know there's been some announcements in specific areas where carriers have needs to refarm bandwidth out from GSM or from 3G services. But for the carriers to really get away from 2G and 3G, then you've got to move to an all LTE network and all subscribers going on to LTE. So that's where I think we are going. I think looking at the speed at which things are developing, and people have talked about that this week, I think we've got a good chance of getting there in the 3 to 5 year time frame. It'll be interesting to see how that development goes. But I think the guys we got on the panel have got a lot of interesting things to say about how we might get there. So with that, Ashok, would you like to just come and give us a short presentation just about where 3GPP is going? Okay.
Thank you, Simon. This is a presentation of trying to shorten a huge, big subject area into a few slides, because we all know that you have not come here to see slides, but to listen to some discussions around what might be ahead in the next 2 to 3 years. It's a very simple, straightforward presentation, few slides, overview of the process, overview of the release timeline. Release, if you don't know, I'm sure that all of you do know what release. It comes as waves, and every release means you can make an end-to-end system design based on that release. There was a all-important RAN is Radio Access Network workshop on release 12 onwards, what's going to happen. We are going to talk about a little about the scope of the workshop, results, and the summary outputs, and the way forward of what's to be seen. 3GPP you have already heard a lot during your professional careers over the past several years. You might not know how it works. Just to give you a pictorial on how it is actually constructed, I was one of the people about 13, 14 years back, put this beast together, had no idea it was going to be that successful. We had high hopes, but it has become beyond all reasonable expectations. Success is an understatement, I guess. If you think that 3GPP is at the center of the universe, which I happen to think, it's owned by actually partners. Partners are the regional standards organizations from around the world. Japan, United States, Korea, China, Europe, they all own it. They are the owners of it. The outputs of 3GPP are taken back to these regions of the world, and they are made into the regional or national standards, and inputs come into what's needed by what we call market representation partners, who have their feet on the ground, who listen to the marketplace, and they tell us that what's to be expected in terms of requirements going forward basis. And everything goes into, at the very end, to ITU. That has a global presence. A lot of the developing world, they think ITU is God's gift. So you cannot ignore that. It has got a huge, big perceptional role to play. ITU takes both on the network side and on the radio side the outputs and makes it into real global standards. You can see the standardization organizations that communicate with 3GPP. These are all the partners and ITU and everything. But on top of it, you would see OMA, IETF. They are not partners. They are not market representation partners, but they are in constant touch. We are in constant touch with 3GPP, between us and them, and then you have the IEEEs, the Wi-Fi Association Alliance, WiMAX Forum. Just you had the announcement a couple of days back here during the conference here that WiMAX Forum has decided to embrace TD-LTE standards to be one of their extended modes. The membership of 3GPP, huge big numbers, very impressive. And it is, all the information is absolutely free. It's a total open website. Go and have a look at it. 3GPP sincerely believes that the only value of standards is if people use it. So there is no reason, there is no expectation of hiding it behind something. This is the release of 3GPP specifications through various stages. You have seen all the way from WCDMA down to the very bottom, you have the release 11 going into release 12. We have got lots of successes. We really don't like calling anything 4G, 5G, 3G, because as we are enhancing LTE, HSPA is being enhanced. So nothing is a standstill sort of thing. So it gives you an idea of how the things are progressing. The all-important workshop that had as its goals to look at the requirements, potential technologies, and the roadmap, what's going to come, release 12, 13, and after. Requirements, the summary. It's very difficult to summarize those in a small summary, but here we have tried to give you what were given to be the major requirements of what we need to see going forward. Energy savings, if you like it or not, it is one of the very important areas. Cost efficiency, backhaul, last definitely not the least. User experience and data rate, very important areas. The summary of workshops, the potential technologies, you will see that there were a lot of meeting of the minds in terms of what interests were shown for the enhanced small cell for LTE. I don't want to spend your time and my time on reading through these. You can always look at those later on. This next slide, the 3D MIMO beamforming, the beams not only in one plane, you want to beamform in both horizontal and vertical planes. You have new procedures and functionalities for LTE to support the control signaling reduction. Signaling is a necessary nuisance. Without it, you cannot live it. But if you want to live, you want to use as few bits as possible. Machine-type communications was very important. There were a lot of interest in interworking with Wi-Fi, machine-type communications, self-organizing networks, minimization of the drive test. If your systems are more context-aware, you don't have to do the drive test that much. Advanced receiver, device to device. When my device would talk to your device, especially important in the disaster situations like Hurricane Sandy. When I want to talk to my colleague next door, I don't have to go through the network if I can help it. Way forward, we are coming to the end of my presentation. The target for the freezing of stage 2 is the end of next year, 2013. And target for freezing of stage 3 is June, 6 months after that, in 2014. You'd see that release 11, that's the pre-release 12. From that stage 3 freezing to release 12 stage 3 freezing is a good, healthy 21 months. So we have got a lot to accomplish. We are pretty positive that we are going to deliver on that one. If you want to, this is again, it's my coordinates. It just so happens that I work for Ericsson, but you don't have to write to me. I'll be more than happy to answer your questions if you want to. But the last contact at 3gpp.org, they're very good in getting back to you. And just go to the 3GPP website, and you can just navigate. It's pretty quick. Thank you.
Thank you, Ashok. And with that, we're going to go on to the first of our questions. So the question is, what are the key challenges in developing the heterogeneous RAN, so that's the RAN that's supporting small, large, and so on, cells? And for both LTE and LTE Advanced, so you've got also to handle higher bandwidths and carrier aggregation and so on from LTE Advanced. And what will be the trade-offs that need to be made there? And perhaps we'll start with Stephen.
Yep. So certainly as LTE starts to roll out, and we're seeing that now, volume of microcell is really taking off. There's going to be challenges, I think, around RF interference, especially with HetNet, with a wide array of small cells in enterprise and at home, and reuse of the spectrum, the interference that will lead to. There's some fairly practical issues as well, which we need to think about in terms of things like backhaul, and how all these cells are going to get backhauled. And even when we start to deploy metro cells in downtown areas, access to street furniture, where are we going to mount these cells, how are we going to provide physical backhaul access to them, and so on and so forth.
Okay, and Noy, what are your thoughts?
Yeah, so obviously once you get used to the speed and the access and latency characteristics of the LTE, you want it more. I mean, it's sort of addictive drug, if you like. So one of the key things to make sure that the data is going to be there for you anytime you want is a heterogeneous network is a necessity evil. But one of the key things for the operators to be able to deploy that network cost effectively. So ease of operability, interference cancellation, interoperability testing across the network will be key. If your user experience deteriorates because the small cells and the macro cells don't work very well with each other, or the frequency interference happens, then at the end of the day, as a consumer, you are not going to be willing to pay the price for that. So I think interoperability, ability to any device or any location to be able to get that access to that bandwidth as well as low latency is going to be key.
Okay. And I'd like to go on to the next question for Ashok. And so what do you feel are the most important aspects of LTE Advanced, and why is that?
I don't want to take sides. Most important aspects is how do you make things, the future, so compelling that we can satisfy the requirements of the previous presenter from Solstice. To quote him, that it becomes totally non-distinguishable in our everyday lives. Now, I like the last comment that he made, that is the network stupid. At the end, if you don't have connectivity, then you don't have this ubiquitous apps being used by everybody all the time. I guess the finding usage of LTE, LTE Advanced, and the future as applicable to not only the heavy users of bit rates, but also scaling it back to the machine where it doesn't have to be always on, but even if it's always on, it's not always communicating. You remember that you push the pizza button, and that could be just a few bits going out. How do you make LTE going forward relevant in this bandwidth hogging applications to the very small bandwidth needed for going forward, especially when we think that 2G and 3G might become non-existent some years down the road. It's not there yet. We as a company and many of our competitor companies are still making a whole lot of money by selling and enhancing 2G equipments. So if you want to make LTE advanced and the future most relevant, I think it has to be equally applicable to all kinds of applications.
Okay, quick thoughts, Stephen?
Yep, I mean, a little bit scary hearing about release 12 and the releases planning beyond that. I mean, I think most of the engagements we have right now and what we're seeing in the market, people are launching LTE initially looking at release 9 and starting to have an eye towards LTE advanced. I will take sides because we have to implement some of this stuff. So there are some important features, I think, advanced MIMO support for good use of bandwidth and high data rates. You know, we're focusing now on up to 8x8 support. Relay mode, I think, is going to be important to address the backhaul issue as one of the ways that people will be able to do wireless backhaul. And advanced interference collaboration techniques is also going to be key for what we talked about with HETNet and self-organizing networks and making sure that we're deploying all these cells and you can actually get access to them and the signals aren't getting jumbled.
Okay, and Noi.
Well, as the technology advances, obviously the complexity which we need to solve that complexity increases. First, I think the end-user device costs have to come down for the global utilization of the technology. That will then determine the coverage. I mean, GSM is popular in the world because two main reasons. Number one, roaming. That's not an issue. There is a world standards for it. And the other one is the cost of end-user devices, even though they might not be RF-efficient technologies, but it allows. So the other thing for us on the semiconductor side is the complexity of the technology LTE advanced come in. The workload which we need to deliver that at power efficiently is going to be key so that we have solutions which can be deployed, cooled, and functioning in various different locations. So it will require some technology changes on the semiconductor side as well.
Okay, and that kind of leads me into my next question. I'll go back to Stephen first. And in what ways do you see future silicon devices for LTE being more integrated, and how is that going to benefit carriers?
Yeah, so maybe disagree a little bit. It's not all about the network, it's all about the money. and it comes down to the CapEx and the OpEx. And for a silicon vendor, that's the size of the silicon for the CapEx and the power that we draw in terms of the OpEx. So one of the nice things about standards, it creates requirements which don't change. And you can accelerate these, and you can put them in hardware. And so the challenge and what we're trying to do is get the right combination of acceleration to accelerate these features that we can and accelerate efficiently together with enough processing performance. And as Noy says, as the standards move forward, layer 1 actually gets more, is simpler than it was for 3G, but the higher level stacks get more and more complex. So coupling the right accelerators with enough high performance processing to optimize the size of the silicon and also keep the power requirements down, because even though as you go into the center of the network and you've got people talking about Cloud RAN and server farms with, you know, perfect cooling setups, there's still, especially with HETNet, there'll be a lot of base stations deployed on the side of buildings, in forests, side of roads. It's going to be hot, and power dissipation and keeping the cost down from power requirements is going to be key. Okay,
and Noy, what are your thoughts?
Yeah, I mean, to add to Stephen's points, obviously they're all definitely valid, but and CapEx and OpEx cannot be ignored. That's definitely very important. Other thing is there's the new standards and the decentralization of the overall network rollout or network model changes. A lot of other accelerators which we don't think about come in. Security, for example. How do you make sure that nobody comes and taps into your network as an operator? Also additional compression techniques to make sure the backhaul loads are managed as the data you, as a user you use is increasing. That has to be somehow find its way to that base station, eNode Bs or whatever they might be. So integration, obviously, of these functions into a cost-effective, small footprint will be important. And that gives a lot of other flexibility in deployment scenarios. And the interference cancellation is going to be a critical element when you have macros and underlying small cells and other femtos, even maybe operating in the various different frequencies and even in the same frequency bands.
Okay, thanks. And for the final question, I just want to... Yeah, sure.
You know, this is not probably directly relevant to this particular question, but I'd like to bring to your notice how the simplest of things can become a bone of contention. We just heard that power consumption is an important thing, obviously. We all know that. But how do you measure efficiency of power consumption? How to measure it? There is no standardized fixed way of measuring that. The community is divided among my way or your way, or in a static measurement as opposed to dynamic measurement and all this. So, you know, it's easy to make a statement general, top-notch, top level, that we have to be cognizant of consumption should be brought down. But when I start making comments that my system is better, then Noy might come and say that, no, my system is better because I've used a different technique. So nothing is easy in this LTE world, but it's still working. So we should be grateful that we are making the progress that we are.
And by the way, as the silicon gets more complex and we're really doing system on a chip with dozens of processing cores and dozens of accelerators, it gets harder and harder to measure what the actual power is. It becomes very dependent on the use case and the loading that's been put and how the silicon is being used. So it gets harder to be absolute when you talk power as well.
And when you are talking about combining carriers in different bands, it becomes that much more difficult. It's, you know, there's nothing static anymore, really.
Yep.
Okay, and I think that sort of brings me into the last question. You know, one of the things we're starting to see in places like Korea, where they've had LTE for just over a year now, take-up's been very good, and that's starting to give operators a bit of a headache because people are actually using the network and starting to fill it up. So things like service level agreements and quality of service is going to become a lot more important on LTE. So the question is, what developments will help carriers address these SLA and QoS challenges? So Stephen, do you want to go first?
Yes, I mean, I think that's one of the drivers behind heterogeneous networks.
Mm-hmm.
That's one of the big things. I mean, today if you phone your carrier and complain about your service, certainly in North America, and they confirm that you're not in a good coverage area, chances are they'll send you a femtocell. A lot of operators have different views on small cells and how they're going to deploy LTE. We're seeing a lot of activity, a lot of interest in the middle range at the moment, kind of enterprise class solutions for providing better in-building coverage, higher frequency spectrum, not so good at building penetration, and also metro cells downtown, providing very dense bandwidth in a small area, so low RF power, but a lot of bandwidth and a lot of processing requirements. I think that's going to be one of the key ways that the operators will provide the coverage and the throughput and the bandwidth for their customers.
Okay, and Noy?
Yeah, I mean, as a service level agreement and QoS becomes fundamental, I think the intelligence on the network has to come closer to the end use, and then it has to be managed closer to the end users, i.e. node Bs potentially more so. Because otherwise, a centralized QoS management is not going to scale, and as control traffic and other things are not going to allow it to physically be implementable. The other thing is, I mean, enterprise, as you saw in the first presentation this morning, as enterprises start using the mobile, I mean, they will expect an SLA, and there are some penalties with it, and so on, with their providers. So that needs to be measured, that needs to be enforced, and that requires a lot of measurements and intelligence to come much closer to the user of that service. And as a result, I mean, you know, one of the key complexities of any new technology, how you do operational measurements, and that has to be done without intrusively as the traffic flows.
Okay, and Ashok, what are your thoughts?
I'll take this opportunity to bring another thing that might not be obvious to this gathering here, but surely, slowly but surely, I think it's happening. And this is relevant for SLA and QoS discussions. The bigger players among the carriers, they have been involved in these kinds of discussions for a long time. What has not happened too much in the past, it did happen, but not too much, was the inputs from the developing countries. Now, they are waking up. In some cases, they are leapfrogging lots of technologies going forward. Yesterday, some of you might have attended a session where Ali Tabasi, he's the chief operating officer of a very successful startup new organization in Malaysia. He spoke about how he's changing his part of the world. We just saw an announcement a few days back that Bharti Airtel from India and Africa also, by combining their networks, they're becoming the 4th biggest operator in the world. So these inputs are going to come in and probably shape the debate on the SLA and QoS. The QoS that we have traditionally dealt with might not be, model-wise, be applicable to all network situations. So it's a really exciting world. And I believe that one size is not going to fit all.
Okay, thanks. And I just want to mention, we've got two guys from device companies here. There's actually a new heavy reading report coming out in the next few weeks that'll be looking at components specifically for LTE. So if you're more interested in that, then take a look at that report when it comes out. And with that, we're now going to go on. We've probably got time for one, maybe two questions from the audience. So are there any questions?
Good morning. My name is Rami from Axel Wireless. My question is mainly to Dr. Ashok. There have been a lot of talking about LTE and Wi-Fi offloading and the way the market is going to seamless integration. I think that nothing will happen until 3GPP publishes appropriate standards for Wi-Fi offload. This is my assumption. My question to you, first, if you agree with me. Second, what is 3GPP doing about this issue? And the third question is, when will this happen? Thanks.
Very simple question, complicated answer. No, answer is also pretty simple. I fully agree with you that the world would come to a dead stop if 3GPP does not publish something. 3GPP has become an engine for so much. So 3GPP, if you probably missed when I was quickly going through my presentations, Wi-Fi integration, and by integration I mean the offload is included in that, is already very much in the radar screen of 3GPP, of the release 12 dialogue that has started. And if you have some specific ideas, specific things, don't even think that it's too late to bring the issues on board. People are waiting for general discussions to start, and there is 21 months. It seems long. It is not long. For the stage 3, I believe the June 2014 is the date that you are looking for that I mentioned in my presentation, and stage 2 is going to be end of 2013. So that gives you some idea of what the time frame we might be looking at.
Simon, maybe just a quick comment on Wi-Fi. I mean, I think we're already seeing, there's a lot of debate, but we're already seeing people looking for physical hardware solutions that support Wi-Fi offload, and it's a really straightforward thing from a silicon perspective. I guess the challenge for a lot of the operators is how to monetize that. With 802.11ac, that starts to give them the opportunity to look at ways of doing that. But we're also seeing now, we have a lot of customers in the Wi-Fi space. They're all now starting to look at how to integrate cellular technologies into their solutions so they can mix and match their air interface support. So it's definitely something that's coming. There's definitely people already looking at how to do that ahead of having standards. And I think having a published standard really help make life easier for the implementers, that's for sure.
Okay, unfortunately we have run out of time, so I'm sorry about that, but do come and see the panelists after if you've got specific questions. So thank you, and please thank the panel today.